All right, so let's solve an equation using a rational number or rational numbers. In this case, we're going to solve an equation that uses fractions. So there are a couple of ways that we can solve this equation. First of all, what I want you to notice is that this one has a variable on both sides of the equation. And so that is something that we're going to have to deal with. And the second thing, of course, is that we've got fractions galore. And there are a couple of ways that you can deal with this. Your first instinct might be to say, well, I don't like fractions. I'm going to turn all of these into decimals. And that's fine. You could solve it that way if you're more comfortable with decimals. We will still be dealing with rational numbers, though, which are not quite as fun as whole numbers. Not quite as easy, I should say, as whole numbers. But turning them into decimals is perfectly acceptable. You might think, I'm not afraid of fractions. I'm just going to leave them as fractions and solve them like that. If you've got a calculator that can handle fractions, there's literally no difference between solving with fractions or solving without. You're just going to make the calculator do all the arithmetic for you. That's fine too. But I think your first instinct is probably the right one, which is I don't like fractions, I don't want to deal with them. But let's not turn them into decimals, because decimals are not much better than fractions, in my opinion. Let's turn them into whole numbers. Okay, so hopefully you're looking at 7/10 and thinking, what are you talking about? How am I supposed to turn 7/10 into a whole number? And the answer is using something that you're probably familiar with going back to, I'm going to guess, fourth or fifth grade, depending on when you learned this. And that is something called a common denominator or the lowest common denominator. The lowest common denominator is the easiest way to do this, but lowest is actually optional. Any common denominator will get the job done. Lowest is just the simplest way to do it. So our denominators here are 10, 2, and 5. So the lowest common denominator, the way that I always think about it is, what is the biggest number, or sorry, what's the smallest number, the lowest common denominator, the smallest number that can be divided by 10, 2, and 5? Now the answer here is 10. 10 is the lowest common denominator because 10 can be divided by 10, 10 can be divided by 2, and 10 can be divided by 5. So 10 is the smallest number that can be divided by all three of these. Okay, great. Does that mean I'm going to rewrite all these fractions so they have a denominator of 10? No, no. That would just make the problem easier for me to do with fractions. And my goal was not to do the problem with fractions. My goal was to get rid of the fractions so that I have only whole numbers. So instead of saying, okay, great, now I've just got easy fractions, my goal is not easy fractions, my goal is no fractions. I'm going to multiply everything in the problem, everything, even the stuff that's not fractions, everything by the lowest common denominator. Okay, so what does that look like? Well, the first thing I had in the problem was 7/10 in. That gets multiplied by 10 plus. The next thing was 3/2. That gets multiplied by 10. It equals 3/5 in. That gets multiplied by 10. Plus 2. That also gets multiplied by 10. I wrote this a little too close to my notes. There we go. Okay. Okay, so how do I multiply a fraction by a whole number? How do I do like 7/10 times 10? And the answer is that you just multiply the numerator by 10. We don't multiply the denominator. Multiplying the numerator and the denominator is bad news bears. That was just make a larger fraction, which is not what we want. So 7/10 times 10 is 70 tenths. 3/2 times 10 is 30 halves, multiplying just the numerator by 10. 3/5 in times 10 is 30 fifths, and 2 times 10, I'm pretty sure is 20. Now you're probably looking at this and thinking to yourself, Taylor, you absolute moron. We still have fractions, but you have somehow made these fractions incredibly bad. You've made the fractions even worse. We had 7/10, which wasn't my favorite, but now I have 70/10, which is way worse than 7/10. What is wrong with you? Well, bear with me. I promise I haven't led you astray. Believe it or not, 70/10 reduces very nicely. 70/10 reduces to 7. So we've got 7 in plus 30 halves is 30 divided by 2, which is 15. Then we've got 30 fifths. That's 30 divided by 5. 30 divided by 5 is 6. And then 20 we don't need to do anything with. It's already reduced. So yes, our fractions temporarily looked horrific and deplorable, but now look at them. It's all whole numbers. Look how nice that is. In fact, not only is it all whole numbers, but our next step, of course, since we have variables on both sides, we've got an n right here and an n right here. Our next step is going to be to get the n's on both sides. We could subtract 7n on both sides if we wanted to, but it's easier to subtract 6n on both sides because if we do, look what we get. Oh my goodness gracious. Happy days are here again. 7n minus 6n is just 1n. And we are now one step away from the answer. Just has to subtract 15, and there we go. N equals 5. We did it. But we took something that was pretty awful and had fractions in it, and we multiplied by the lowest common denominator so that we would no longer have fractions. We had only whole numbers. Now I want to go back and look at this step right here because I wrote out the next step right here with these big numbers. And if you were wondering, is there a way we could avoid that step? The answer is, why, yes, as a matter of fact, there is. So let's take a look at just this step here, because there's a way we could sort of simplify things at this step. Look right here. We're going to have a 10 in the top and a 10 in the bottom. Those can just cancel and leave us with 7 in. Here, we will have 10 over 2. 10 divided by 2 is 5. So we'll have a 3 times 5, which is going to give us 15. Here, we had a 10 in the top and a 5 in the bottom, and 10 divided by 5 is 2. So we had 3n times 2, which is going to give us 6n. And then, of course, 2 times 10 is just 20. And this comes out to be exactly the same as what we had right here. So it is possible for us to reduce before multiplying, and that can save us writing a step if you can reduce before you multiply. And doing it either way is fine. You can multiply and then reduce, or you can reduce and then multiply, whatever you like the best. But there is a way to sort of reduce the amount of writing you have to do as well. So solving these equations with fractions, multiply by the lowest common denominator first so that you just don't have any fractions. And once you don't have any fractions, it's a pretty simple problem to solve.